We can write functional residual capacity or FRC is equal to residual volume or RV plus expiratory reserve volume or ERV. Very good. FRC is equal to RV plus ERV. And FRC or functional residual capacity is about functional residual capacity is about 2100 to 2300 ml. Very good. Alright. The volume of air remain in lungs after normal expiration is a functional residual capacity or FRC. Very clear. But the volume of air remain in lungs after forcible expiration is called. The volume of air remain in lungs after forcible expiration is called residual volume or RV. Very good. Now expand IC. Expand IC. Inspiratory capacity. Right. What is inspiratory capacity or IC? The volume of air. The total volume of air, very good Soumya. The total volume of air a person can inhale after normal exhalation, very good. The total volume of air a person can inhale after normal exhalation is called inspiratory capacity or IC. No, wrong Uday Kiran, mister. The total volume of air a person can inhale after normal expiration or after normal exhalation is called inspiratory capacity or IC. Inspiratory capacity or IC is equal to tidal volume plus inspiratory reserve volume. TV plus IRV. Inspiratory capacity or IC is equal to tidal volume or TV plus inspiratory reserve volume or IRV. Here, inspiratory capacity or IC is about 3000, very good, 3000 to 3500 ml. Okay, now expand EC. Expand EC. Expiratory capacity. Define the term EC or expiratory capacity. Define the term EC or expiratory capacity. The total volume of air a person can exhale, very good, after normal inhalation. The total volume of air a person can exhale after normal inhalation. Okay, now the total volume of air a person can exhale after normal inhalation is called expiratory capacity or EC. Expiratory capacity or EC is equal to tidal volume or TV plus expiratory reserve volume or ERV. Expiratory capacity or EC is equal to tidal volume or TV plus expiratory reserve volume or ERV. And expiratory capacity or EC is about, very good, 1500 ml to 1600 ml. 1500 ml to 1600 ml. Expand VC. Vital capacity. Very good. Define the term VC or vital capacity. Define the term VC or vital capacity. Yes, the maximum volume of air a person can inhale after forcible exhalation. The maximum volume of air a person can inhale after forcible exhalation, or the maximum volume of air a person can exhale after forcible inhalation, vice versa. The maximum volume of air a person can inhale after forcible exhalation, or the maximum volume of air a person can exhale after forcible inhalation is called vital capacity or VC. Vital capacity or VC is equal to tidal volume plus inspiratory reserve volume plus expiratory reserve volume, or VC is equal to TV plus IRV plus ERV. VC is about 4000 to 4600 ml. Very good. 4000 ml to 4600 ml. And last one, expand TLC. Expand TLC, total lung capacity. Define the term TLC or total lung capacity. The total volume of air remain in lungs. The total volume of air remain in lungs at the end of forcible inspiration. Very good. The total volume of air remain in lungs at the end of forcible inspiration. The total volume of air remain in lungs at the end of forcible inspiration is called total lung capacity. We can write total lung capacity or TLC is equal to TV plus IRV plus ERV plus RV. Total lung capacity is equal to tidal volume plus inspiratory reserve volume or IRV. Total lung capacity or TLC is equal to tidal volume or TV plus inspiratory reserve volume or IRV plus expiratory reserve volume or ERV plus residual volume or RV. Just a minute here. TV plus IRV plus ERV is equal to VC. TV plus IRV plus ERV is equal to VC. So we can write TLC is equal to VC plus RV. TLC is equal to vital capacity or VC plus residual volume or RV. Total lung capacity or TLC is about 5100 ml to 5800 ml. So write the tabular form of different respiratory capacities. Serial number, respiratory capacity and value. Number one. Just a minute, right? No need to write serial number because space is not sufficient. Respiratory capacity. Analysis. Value. Please write down everyone. Number one. Functional residual capacity or FRC. Analysis, functional residual capacity or FRC is equal to residual volume plus expiratory reserve volume. Residual volume plus expiratory reserve volume. FRC or functional residual capacity is about 2100 ml to 2300 ml. And the second one, inspiratory capacity. Inspiratory capacity or IC. Analysis, Inspiratory capacity or IC is equal to tidal volume or TV plus inspiratory reserve volume or IRV. Inspiratory capacity or IC is about 3000 ml to 3500 ml. And third one, expiratory capacity. Expiratory capacity or EC. Expiratory capacity or EC is equal to tidal volume or TV plus expiratory reserve volume or ERV. And expiratory capacity or EC is about 1500 ml to 1600 ml. Next, vital capacity, fourth one. Vital capacity or VC. Vital capacity or VC is equal to tidal volume plus inspiratory reserve volume plus expiratory reserve volume. The vital capacity is about 4000 ml to 4600 ml. Last one, total lung capacity. Total lung capacity or TLC. Total lung capacity or TLC is equal to tidal volume plus inspiratory reserve volume plus expiratory reserve volume plus residual volume. Don't confuse. Total lung capacity or TLC is equal to tidal volume plus inspiratory reserve volume or IRV plus expiratory reserve volume or ERV plus residual volume or RV. Here TV plus IRV plus ERV is equal to vital capacity. TV plus IRV plus ERV is equal to VC or vital capacity. So instead of TV plus IRV plus ERV, we can write VC. So TLC is equal to VC plus RV. Vital capacity plus residual volume. Total lung capacity or TLC is about 5100 ml to 5800 ml. Please note down, everyone. Please note down. Thanks, sir. Finished up? Please respond. Yesterday's class not uploaded. Array, don't send like that again. I am not responsible for that. I am not responsible to upload those videos. Don't ask again, please. I better to make phone call to Sangamesh sir. Eight 55 080 4676. For video uploading issues, please make phone call to 8550804676. His name Sangamesh sir. Understood? Please make phone call to 8550804676. His name. Sanghamesh sir. Okay na? Announce sir. Okay na? Have you written this? Okay na? So due to network issues, we didn't upload those videos. Again started. Video is not clear. Again started. Right, Ra? Sir. Remove the chat box. Voice is blur, video is blur, voice is not clear, audio is not clear, video is not clear. Ignore all idiotic thoughts. Please keep concentration on this. Okay, na? Ignore all idiotic thoughts. Right. Next topic. Exchange of gases. Listen carefully. Alveoli are the primary sites for gases exchange. Alveolar ducts end in alveolar sacs. Alveolar sacs end in alveoli. We have discussed about that in previous class. Respiratory bronchioles, alveolar ducts, alveolar sacs, and alveoli constitute exchange or respiratory part. Respiratory bronchioles, alveolar ducts, alveolar sacs, and alveoli constitute exchange or respiratory part. Exchange or respiratory part is the actual site of gases exchange between blood and atmospheric air. Already you know that. We have discussed about that in previous class. Okay, na? Alveoli are the primary sites for gases exchange. Alveoli are the primary sites for gases exchange. In general, exchange of gases like oxygen and carbon dioxide. Exchange of gases like oxygen and carbon dioxide occurs between blood and the tissues. Exchange of gases like oxygen and carbon dioxide occurs between blood and the tissues by simple diffusion. Understood? Alveoli are the primary sites for gases exchange. In general, exchange of gases like oxygen and carbon dioxide occurs between blood and the tissues by simple diffusion. My dear students, exchange of gases depends on 5 factors. Exchange of gases depends on five factors, or simply you have to say five factors show their influences. Five factors show their influences on exchange of gases like oxygen and carbon dioxide. Factor number one, partial pressure. Factor number two, solubility of gases. Factor number three, surface area. Factor number four, diffusion distance. Factor number five, thickness of respiratory membrane. I will explain all these factors individually. Don't worry. I will explain about these factors individually. Exchange of gases depends on five factors, namely number one, partial pressure. Second one, solubility of gases. Third one, surface area. Fourth one, diffusion distance. Fifth one, thickness of respiratory membrane. Alveoli are the primary sites for exchange of gases. In general, exchange of gases like oxygen and carbon dioxide occurs between blood and tissues by simple diffusion. Five factors influence exchange of gases, or five factors affect exchange of gases, or five factors show their influences on exchange of gases, like number one, partial pressure. Second one, solubility of gases. Third one, surface area. Fourth one, diffusion distance. Fifth one, thickness of respiratory membrane. Please note down, everyone. Please note down. Completed? Please respond. Have you written this? Please respond. Is it clear? Audio, video? Okay, na? Alveoli are the primary sites for gases exchange. Exchange of gases. What is blur? Just a minute. Now, is it clear now? Board is blur. Ayyo. It's okay. Blur. Very clear. Clear? Everything is clear. Okay. Sorry for inconvenience. When offline classes begin, I will explain digestive system chapter 1 again. Don't worry, please. I will explain digestion and absorption unit again. Okay? Okay. Alveoli are the primary sites for gases exchange. Exchange of gases like oxygen and carbon dioxide occurs between blood and tissues by simple diffusion. 5 factors show their influences on exchange of gases like oxygen and carbon dioxide. Like number 1, partial pressure. Second one, solubility of gases. Third one, surface area. Fourth one, diffusion distance. Fifth one, thickness of respiratory membrane. Okay, na? Dear students, sir, factor number 1, partial pressure. In a mixture of gases, the pressure exerted by an individual gas in a mixture of gases, the pressure exerted by an individual gas is called partial pressure. In a mixture of gases, the pressure exerted by an individual gas is called partial pressure. For example, partial pressure of oxygen means the pressure exerted by oxygen in a mixture of gases. The pressure exerted by oxygen is called the partial pressure of oxygen. The pressure exerted by an oxygen is called the partial pressure of oxygen. Here, partial pressure of oxygen is represented as PO2. In a mixture of gases, the pressure exerted by an individual gas is called partial pressure. In a mixture of gases, the pressure exerted by an oxygen is called partial pressure of oxygen, and partial pressure of oxygen is represented as PO2. And partial pressure of carbon dioxide. In a mixture of gases, the pressure exerted by carbon dioxide. In a mixture of gases, the pressure exerted by carbon dioxide is called partial pressure of carbon dioxide, and the partial pressure of carbon dioxide is represented as PCO2. In a mixture of gases, the pressure exerted by an individual gas is called partial pressure. The pressure exerted by an oxygen is called partial pressure of oxygen. And partial pressure of oxygen is represented as PO2. And the pressure exerted by carbon dioxide is called partial pressure of carbon dioxide. And partial pressure of carbon dioxide is represented as PCO2. Please note down. Up to Thursday. Happy. Any problem? Okay, Ra. Thank you, Ra. I have some work. Tomorrow we will discuss about partial pressure of oxygen and partial pressure of carbon dioxide in alveoli, tissues, oxygenated blood and deoxygenated blood. Thank you. Thank you. Thank you, one and all. Have a nice day.